All right, so I'm gonna get started. My name is CM, and I am gonna do some work with you guys on AP Physics C, and then specifically mechanics. We are not gonna be covering the EM exam today. Some of you may also be taking that exam, but I'm not gonna be covering that. All right, and so all of you know that we're going to have a little bit of a different format this year. There's no multiple choice. It's just 2 free response questions, one right after the other. And they've given us a little bit of, detail about what kind of questions they're going to ask us. All right, so they are going to be giving you a long one and a short one. The long one looks like it's going to be very conceptual, so they might ask you a lot of conceptual questions that have to, deal with the, physical properties of things. I personally find that if you can actually do the physics, then you can answer the questions pretty easily. So I'm not sure I would prepare necessarily any differently than I would for the normal AP exam. All right, and then the second one is going to be one of their experimental design questions. And I'm not sure if the one that I chose to go over today has one of those, but we'll see. All right, and then I did want to just let you guys know that they are telling us that units 1 through 5 are on the exam, and then units 6 and 7 are not. And so what that means for you guys is that unit 6, which is oscillations, and then unit 7, which is gravitation, are not on the exam this year. All right, so no pendulums, no springs, and then no law of gravitation or Kepler's laws. All right. Does anybody have any questions before we get started? Yes, no? In the chat box? No? Okay. All right, so I had you guys take a look at the 2017 free response questions. Will we have access to the session recording after? I believe that it is being made available to you by our partners at Wyzant. So I believe yes. No problem. Right, so those of you who are auditory learners, sit back, relax, and, stay along for the ride. You will be able to take notes later. All right, so I'm going to go ahead and put up the first question. Does this look familiar to everybody? Everybody seen this? Fantastic. It's always a good sign. All right, so an Atwood machine consists of 2 blocks connected by light strings passing over a frictionless pulley. That means that I don't have to worry about the moment of inertia of the pulley, which is great. As shown in the figure above, the masses of the 2 blocks, M1 and M2, are varied, and they tell us here that M2 is greater than M1. Okay. All right, so what this means, and I will show you how I do this, is that the direction of motion for these 2 blocks is going to be different, okay? And CM's rule number 1 of physics is always take the direction of motion to be positive. So we'll see what that means in a second. Okay, so the first thing that they want us to do is to draw a free body diagram. All right, and we are going to denote the length of the arrow as being important for the force, okay? So let's start with M1. So does everybody agree that there are two forces acting on mass one, just gravity, and then the force of tension? Everybody agree with that? Yeah? Great. So I am going to denote this as maybe 2 lines as M1G and maybe 3 lines here as the force of tension. All right. And then over on mass 2, we know that mass 2 is greater than mass 1, so this gravity vector is going to be longer. So I will say that maybe I'll be a little more careful. All right, that this is M2G. All right, and that this is my force of tension. All right, and then 2 things here I'm going to note that M2G is greater than M1G, so it needs to be longer, and that the tension for both are the same. And I will answer that question in a second. All right, and so let me just make one comment here. The tension vectors, I should say the magnitude of the tension vectors is the same because this is a connected system. All right, there's nothing interrupting the tension vector. All right, this may not be the case if we had a frictioned or a massful pulley, but this is the case when we have a frictionless massless pulley. Okay, so everybody good on part A? Everybody happy? All right, so now Dan, I'm going to answer your question when I come down to answer part B. All right, so part B asks us to use Newton's laws for each block to get the acceleration of the system. All right, and this is where taking the direction of motion to be positive is going to be really helpful. All right, so does everybody agree that for block number 1, since it's less mass, it's going to be going up? All right, and then mass 2 is bigger, so it's going to be going down. Everybody agree with that? Yeah? Okay. So for mass 1, the direction of motion is positive up and negative down. All right, and then it's reversed for mass 2. All right, and I'm going to set it up that way because it's going to make the algebra a lot easier than if we didn't do it this way. All right, it's going to make the algebra a lot easier. All right, so let's start with mass 1. All right, so mass 1, what we're going to do is use Newton's second law. All right, Newton's second law is that the sum of the forces, and I'm going to specify that it's the y direction, is going to be equal to m, and then acceleration in the y direction. All right, now for mass 1, if I look at my free body diagram, the up vector is tension. All right, and then I'm going to subtract M1G, and I'm going to equal that to M1A. Does everybody agree with that? Yeah? Fantastic. Now I'm going to do the same thing for mass 2, except that my direction of motion is different now. All right, so for mass 2, I'm going to consider positive to be down. So what is the positive vector? M2G. All right, so M2G minus the tension vector is equal to M2A. All right, and then now that I have the 2 equations, because of the way we set up the problem, it's really easy for us to just add the 2 equations together, and when we do that, the tension vectors drop out. All right, one's positive, one's negative, so they go away. All right, and then I'm left with M2G minus M1G is equal to M1A plus M2A. All right, they've given us what we want to get to, so we just need to start factoring to make this look pretty. All right, so first thing I'm going to do is factor out that G on the one side. and I'm going to factor out the A on the other side. And then divide by my M1 plus M2. All right, and then divide, and there's my answer. All right, does anybody have any questions on how we approach that problem? A little bit of a nightmare if you don't take the direction of motion to be positive. All right, Dan, did that answer your question? So I take the direction of motion to be positive. What if you don't know the direction of motion? That's a good question. So if you don't know the direction of motion, then you can guess. And the worst thing that happens is that you get the negative of the answer, right? If I had guessed incorrectly, then I would have gotten M1 minus M2. And I would have compared to the answer and said, oh, well, I got the direction of motion wrong. All right, but here they gave you the clue that M2 is greater than M1. All right, so the magnitude would have been the same. And the magnitude of the acceleration would have been the same. Does that make sense? We just would have gotten the direction wrong. But again, they gave you the context in the question. Okay, I have a question. Why does the tension need to be longer than the weight force? So actually over on this side, that's a really good question. So I actually should make a small correction here. So this weight vector should be larger than this tension vector, okay? But this tension vector should be larger than the M1G. All right. Otherwise, we would have equilibrated the system. All right, and we wouldn't have gone anywhere. Does that make sense? So this one should be longer. Yeah. Otherwise, we literally would have equilibrated. No, great question. Really good question. Okay, so now we're getting into the type of stuff that they are going to be more likely to ask you because we're going to start to get conceptual in nature. All right, and I actually think that the second question's a little more computational, the rest is a little less computational. All right, now we're going to get into some data. All right, so let's go ahead and I'm going to minimize this a little bit so I have a little more room. All right, move that up there. Everybody hanging in there? Yeah. All right. All right. Okay, so here we're given some data. Okay, so magnitude of acceleration A was measured for different values of M1 and M2, and we have some data. All right, indicate which quantities should be graphed to yield a straight line whose slope can be used as a numerical value to find the acceleration due to gravity. All right, so what we just found is that A is equal to M2 minus M1 over M1 plus M2 and G. All right, so it looks a little scary here, but this is essentially y is equal to, I'll just say m for slope times x. All right, and so how would I go about figuring out, well, let's see. So we want G to be m, right? All right, everyone, your microphones. So they tell us that the slope is going to be G. All right, so does everybody agree that for a straight line, what I want is this thing to be x? So maybe I rewrite the equation as y is equal to G, and then I can say m2 minus m1 over m1 plus m2, and I can call this thing x. Does everybody agree with that? So that's what we're looking for here. All right, and so then your y-axis is going to be your acceleration, and your let's see, your horizontal axis, your x-axis is going to be this quantity m2 minus m1 over M1 plus M2. It's also okay if you reverse those because you would still get a straight line. The slope would have just been negative. All right? Does that make sense? Everybody good? Okay. No questions. All right. Okay, so now we are going to plot the data. So I think that this is more in line with, maybe what they're going to ask you in terms of experimental stuff. All right. So I feel like this is fair game. Good exercise. All right. Can everybody see that? Is that a little too small? Okay. All right, so what we'll do here is just essentially plot the points. I'm going to go ahead and use A and then M2 minus M1 over M1 plus M2. All right, so I'm going to go ahead and let's see. We can go ahead and maybe get these quantities. All right, so 2 minus 1 is 1. 12 minus 5 is 7. 2, 4. Bear with me, guys. All right, and so then the quantity, I'm going to go ahead and erase below so I have some more room. How many of you guys are taking multiple exams this year? Lots of you? I had one year I took 7 of them. It wasn't a good 2 weeks. Yeah, it was very misguided. Okay. All right, any issues with that? So all I did here was I took the quantities and then I did the calculation. All right, and so then let's go ahead and make those 0, 1, 2, 3, 4, 5. And it looks like I've got to go up to maybe 0.5. So 0.1, 0.2, 3, 4, and 5. We can just plot our points. So 0.33, acceleration is 3. So somewhere up here. All right, 0.2, my acceleration is almost 2. All right, 0.4, acceleration up here. All right, a non-artist, not to scale. 0.14, 1.15, and 0.167, 1.7, so something like that ish. Not a great artist. All right, let's remember to mute our microphones. And all right, I'm gonna go ahead and draw a line in there. All right, looks something like that. Okay, everybody good with that? Yes, fantastic. All right, and then, so, now, okay, so now here is the tricky part. All right, so for this particular exam, they wanted a line of best fit. All right, so does everybody know how to do that on their calculator? No. All right, so does everybody have something similar to a TI 83, 84, something like that? Yeah? All right, so I'm gonna go ahead and just show you how to do that, all right? I actually don't think it's a waste of time, okay? All right, so what we're gonna do, everybody have their calculators? Well, even if you don't, you can listen. All right, so if I look at the calculator screen here, all right, this is gonna be my second button, all right, and then I have mode, delete, alpha, my variables, and then right there is a button that's called stat. All right, if I hit the stat button, it brings up a function that is called edit, right? And so in edit, I'm gonna go to edit, right? So stat edit, all right? And then you're gonna see list 1, list 2, ... Everybody see that? Yeah? Fantastic. All right, so if you have stuff in your list, you need to clear them. You do that by just hitting the clear button and then the enter button. All right, and then in list 1, what we are gonna do is put the X values, which are these, okay? And I'm just gonna go in order that I have them. So in list 1, I'm gonna write 0.33, 0.2, 0.41, 0.14, 0.167. All right, and I'm gonna actually go ahead and do that. Okay, so I have 5 numbers in list 1, and then I'm gonna scroll over and do the same thing in list 2. I'm gonna put the accelerations. All right, and really good to go in order. You're gonna get results that are messed up if you don't go in order. Okay, so 3.02, 1.82, all right, 4.21, 1.15, and 1.71. All right, so now we should have lists 1 and 2 all populated. Is everybody with me? Okay, great. So then I'm gonna quit and go back to the main screen, and then I'm gonna hit stat again. And then I'm gonna go over to calc. So instead of edit, I'm going over to calc. So stat calc, and then if you go down, you're going to see 4, which is ln reg, all right? And then it says ax plus b, all right? If 4 is not ln reg, you're going to want to pick ln reg, all right? And I'm going to just pick ln reg, all right? And then we just do, all right, so then you hit ln reg, it should put in ln reg on your front screen, and then you hit the second button, second, and then 1, brings up list 1, and then you hit the comma button, which is right above the 7, and then you hit the second button, and then the 2, which brings up list 2. So your screen should read right now, ln reg, ax plus b, L1, comma, L2, and then you hit enter. All right, and then what I got was y is equal to ax plus b, a is 10.52, and b is negative 0.24. All right, did everybody get something similar-ish? All right, so then using your straight line, determine an experimental value for g. We just found it. All right, so what you would have to write is that calculated via linear regression. All right, and then write your calculator. So I have a TI 83 plus. Give them this. You would write this down and then just say G is equal to the slope, which is 10.5 meters per second squared, and don't forget your units. All right, and that would give you full credit. Now, if you didn't have your calculator, you can just pick 2 points and find the slope. All right. So those of you who have not ever done that, now you know how to. All right, any questions? No? Awesome. Are we doing okay? Awesome. You guys are not very talkative. All right, must be a long day. Okay. All right, so everybody ready for parts F and G? So these are more conceptual type questions. Well, thank you. Almost like we knew what we're doing. All right, so these are a little more conceptual. All right, and we will do our best to kind of work through it. All right, I'm gonna fall back on actually showing you the physics, okay? All right, so our experiment is repeated with a modification. So now we set it up so that the block M is on a smooth horizontal table and M2 is hanging over the side. Great. So for the same values, what is the magnitude of the tension? Okay, so, all right, so I'm going to start by drawing a free body diagram. So everybody agree this is going to be M1G, and then now I have a normal force. And then this is tension. All right, this guy is M2G and tension. Everybody okay with that? What tips do you have on preparing for the AP? That's a good question, and that's okay. So if it were me and I was studying, I would take all of the AP physics one mechanics for your response and just hammer them, all of them. All right, and then when you run out of them, I might go back to AP Physics 1 and do the mechanics questions. I don't necessarily think that going through the multiple choice is super helpful, but I don't think that they're going to fundamentally think about the physics differently this year than they have in previous years, and there's only so many ways to ask these questions. So if it were me, I would just do all the free response. All right, and we have about a month, so we can get a lot of that done. Apologies for that. I would do AP Physics C Mechanics, and then like prior to the exam changing, you would go to AP Physics 1 and just do the mechanics questions. All right, they used to be merged. All right, so let's compare this situation to the other situation. All right, I had M1G and tension. I had it going over a pulley, terrible pulley, to tension and M2G. All right, so which situation do we think is going to have the higher tension? So just do some logic. What do you think? Wouldn't they be equal? So what I'm looking at over here is that I have this and this pulling on that rope. All right, and so I'm gonna let's think about this in a real world example. Let's say I take a rope and I throw it over a tree. All right, do I have more tension in the rope if, let's say, I have two people on each side pulling on it? Or maybe I can tie the rope to the top of the tree and only one person pulls on it. Which one do you think is going to have more tension? The two people, right? Because there's more weight. And so same situation here. All right, I have two weights pulling on the rope versus just the one weight. Okay, and then we can note here that the tension is in the y direction here, and then tension is in the x direction there. And so what do we know about the x and y directions? They're independent, right? So we only have one tension vector to deal with. So let's see. So for this question, for the same values, M1 and M2, is the magnitude of the tension higher or lower than in the first experiment? Well, it's lower. All right. Why is it lower? Because since this block is on the table, your net force is gonna increase, right? I have less stuff pulling away from it. Does this make sense? I'd be happy to actually work it out for you if you actually want to see the math. Some people are very mathematically minded. I'm perfectly happy to do that. Absolutely. Math is my jam. All right, so in the first situation, A was M2 minus M1 over M1 plus M2G. All right, so let's go ahead and set this up here. So for M1, I have tension. All right, let's make our direction of motion, positive and negative. All right, so tension is equal to M1, right? And then for mass 2, let's make our direction of motion down. All right, so M2G minus T is equal to M2A. Everybody with me? I've got two equations. I now get to add them. So this drops out, and then I get M2G is equal to M1 plus M2A. All right, I can factor out that A, M2G over M1 plus M2 is my A. All right, if you wanted to plug some numbers in, you could, and then you could prove it to yourself if you wanted to. All right. So then last question here. The value determined for the acceleration due to gravity is lower. What? Than the first experiment. Give one physical factor that could could lead to this. All right, so what's different about this situation than the other one? We got a table. What do we know about tables? They're made of material, right? And so even though it's smooth, it doesn't say that it's frictionless. So we can say that block M1 will experience some amount of friction. All right, and so if we have some friction, what's going to happen to my acceleration? My observed value for acceleration, what's going to happen? It's going to decrease. All right, why is that? Let me go ahead and draw a free body just for fun. All right, here I have my force of friction and I have tension. All right, so if I set up this equation again, T minus the force of friction is equal to M1A, so I'm subtracting something out, so therefore my acceleration decreases. Okay, so if my acceleration decreases, the slope of my line would decrease, and therefore the value of G would decrease. All right, does that make sense? All right, I'm going to point out one thing. It's not asked by the question, but I feel obligated to answer it anyway. Let us remember. So let me finish this thought and then I'll answer the question. So let's remember how we define friction. So let's remember that friction is equal to some mu k or mu s, all right, coefficient of kinetic friction times the normal force. All right, this is the definition of friction. It's always going to be useful if you know that. All right, so for mass 1, if I wanted to define friction here, my force of friction would be some mu k, they would have to give it to you, times m1g. All right, I feel obligated to point it out since we just invoked friction. Can we put what you said, or do we need to explain the slopes line? You can just put what I just said. All right, I was making the connection back to the experiment, but you did not need to invoke the line to get that correct. No problem. All right. Okay, so we are only going to do part of question 2. We're only going to do the part that has absolutely nothing to do with the spring. Okay? All right, because remember, oscillations are no longer on the exam. So we got that one for free. Okay? So we only have to do part A on this one. All right, so everybody can forget Hooke's law. You can forget springs. Does anybody have any questions about any of the concepts that I went over? No? Okay, great. Killing it then. All right, so we only have to deal with the first part of this question because oscillations and springs are no longer on your exam. All right, so yay for something you don't have to know. We will have to know about springs for conservation of energy. I do not believe so. Because you don't know how to do forces of springs without oscillations. So I do not believe so. I would be happy to go through that if we want to. I don't believe so, but we can cover our bases and do it anyway, if you'd like. Happy to do that. We will do that then. All right, so let's read the question. A block of mass m starts at rest, so that's helpful. I have an initial velocity of 0. All right, and we can already tell that this is a conservation of energy question. It almost always is when you have something starting at high and going low. It's the first thing you want to think of. So I know at this point up here, all right, I have kinetic energy initial plus potential energy initial, and that kinetic energy initial is 0 because I have no velocity. Awesome. All right, and we have this at the top of an inclined plane. All right, the block travels down the plane, makes a smooth transition to a horizontal surface. I'm gonna go ahead and point out that at this point, I have kinetic energy and potential energy, but my potential energy is now gone because I'm gonna define H as 0 here. All right, so I only have kinetic energy. All right, and then we're going to go across the surface, collide with the spring, and that's that. Okay. Derive an expression for the speed of the block just before it collides with the spring. Okay, so I'm going to use conservation of energy here. So my potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final. All right, what's my potential energy initial? Okay, mgh, awesome. And then this is 0 because I am at rest. All right, and then down at the bottom, h is 0. So I'm setting mgh equal to 1/2 mv squared. All right, I can drop out those m's. So v squared is 2gh. So v is equal to the square root of 2gh. All right? Does everybody agree with that? Awesome. Okay, any questions? Is it okay if we don't show canceling out the energy? I think if you just wrote like U is equal to K, I feel like that's okay. But if I didn't do it, somebody would ask. Okay. All right, is the speed halfway down the incline greater than, less than, or equal to 1/2 the speed at the bottom of the incline? All right, so how would I go ahead and solve that? Here's how I would solve that. I would kind of understand that this is h over 2, and I'd do the exact same calculation. All right, so I would start with mgh, and I would be setting, let me see, is the speed halfway down the incline greater than, less than, or equal to 1/2 the speed at the bottom of the incline? Okay. No, I mean, okay, so here's the question. The question is, But on the AP, I feel like it's best to just write down all of what you're thinking because we don't know what the graders are looking for. Agree it's better to be explicit than not explicit, and you're more likely to get points if you actually justify things. So, agreed. Okay, I'm gonna go back to this. So here, MGH. So I'm gonna go ahead and set this equal to mg and then h over 2 because I've come down to h over 2 plus 1/2 m and then I'll say v prime squared. Is everybody with me? I can still drop those m's. Is everybody with me? So here I have all potential energy, and then at this point I have some potential, some kinetic, and I'm just denoting it v prime because it's not the same velocity as down here. So just a different velocity. Okay, so then if I subtract this, gh over 2, then I get gh over 2 is equal to 1/2 v prime squared. All right, that's cool. And then v prime squared is equal to just gh, and then v prime is the square root of gh. All right, and then we have to compare, and this is off by a factor of square root of 2. All right, does everybody buy that? All right, and so square root of 2 is about 1.4. So the speed should be greater than half. Does that make sense? Is the math the justification? Okay, so I personally am a very mathematical person. So I would personally need the math in order to figure out what the heck went on. So I would say yes, but you needed to get that it was a factor of square root of 2. You didn't have to necessarily show this, but you had to say that it was off by a factor of square root of 2. Does that make sense? No problem. All right, I'm gonna minimize this and then I'll put up part B. I don't think part B is tested, but I will go ahead and do it anyway because you guys are asking about it. All right, I know for a fact part C is not tested, so we will not go over that because we don't need to know the period because that is squarely under oscillations. All right, just derive an expression for the maximum compression of the spring. Okay, so what I would do is start with what I know, which is potential energy initial, right, which is mgh. And the maximum compression of the spring is your elastic potential energy, and I'll call that final. And then you guys already knew that elastic potential energy is 1/2 k x squared. All right. And so then we just need to solve for x. All right. So 2 mgh over k is equal to x squared. So x is the square root of 2 mgh over k. All right. All right, everybody good? Nice. All right. Killing it. All right, so I'll just say it for the recording. We're skipping parts C through E because oscillations are no longer covered on the exam. All right, everybody hanging in there? Yeah? Awesome. All right, so looks like we have a real interesting system going on here. All right. Okay, uniform solid cylinder of mass M, great, and radius R is released from rest, rolls without slipping, that's important. Down a 1 meter incline, and we got a 30-degree angle. And then it is launched horizontally, which means we're going to get a kinematics question. And the cylinder lands DOA. Smooth transition, that's great. So we lose no energy, that's awesome. And then we have a rotational inertia. Okay, so we'll get to that when we get to it. So let us start with A, the kinetic energy of the cylinder as it reaches the table. So this one should not be terrible. All right, this is going to be your potential energy at the top. And then it's going to equal the kinetic energy at the table. All right. So we should say that this is mgh. Everybody agree with that? Yeah? All right. So mgh. Okay. So now here is the fun part. So we don't actually know what h is, do we? So I'm going to label this as h. All right, and I know that sine of 30 is equal to opposite over hypotenuse, so that's h over 1. So h is going to be equal to sine of 30. Is everybody with me there? Awesome. All right, so yeah, a little tricky if you didn't notice that 1 was not the height. All right. So let's be careful with our units, 0.5 kilograms, 9.8 meters per second squared, and then I need sine of 30, all right, and this ends up being 2.45, and then the units of energy are joules. All right, does anybody have any questions on part A? All right. Okay, so now for part B, we want to know what is the angular velocity of the cylinder when it reaches the floor. Okay, so what we need to do here is set up an expression for kinetic energy, all right? And we can't just take translational kinetic energy, we need to take both translation and rotation. All right, so I need the linear kinetic energy and the rotational kinetic energy. Everybody with me? All right, it's moving forward and it's spinning. I always think of a diver. All right, so K is equal to 1/2 mv squared, that's our normal, plus 1/2 I, and then omega squared. So I is that moment of inertia, and then omega is what they're asking us about. That's the angular velocity. Is everybody with me so far? All right, great. So then K is going to be equal to, so I'm going to go ahead and put in my mass and my rotational my rotational energy. So K here is going to be equal to, so K, there's K. All right, K is equal to 1/2, and then mr squared omega squared. And then I've got to take this bit into account here. So 1/2 times my moment of inertia, which is 1/2 m r squared omega squared. All right, and then we're going to do a bunch of algebra and simplify. So 1/2 m r squared omega squared plus 1/4 m r squared omega squared. All right, if I put that together, I get 3/4 m r squared omega squared. All right, and then this is equal to K. All right, and then we just need to solve for this, do a little algebra, and then substitute it all in. All right, so unlikely that you're going to get something like this on your exam because they're not asking super computational questions. That said, probably good to at least know how to set it up. Okay, so omega squared is 4K divided by 3mr squared, and then I need to square root that thing. All right, so 4, and then we just solved for K, so 2.45. All right, and then 3 times 0.5 times 0.1 squared. All right, and when we put everything in, we got 25.6, and then we have to be real careful. This is radians per second. All right, probably super, that's a super difficult problem. All right, really hard. All right, questions. All right, so I'll just make one thing super clear. All right, if I wanted the mass, the little m for kinetic energy, we're rotating around that moment of inertia. So when I substituted this in, I chose this, all right, because it's a cylinder, okay? All right, you're not gonna have anything too much more difficult than that. Okay. All right, so then for part C, okay, you are confused. How do we know that's the angular velocity when we hit the floor? Because all of our kinetic energy that we got from moving down the incline has to get transferred. Again, conservation of energy. All right, I think this one is outside the scope. All right, I don't think that we're gonna have those types of computations according to what they actually have said. All right, in their actual statement. Why does the M become big M? Because I've got to take into account the total mass of the solid cylinder, uniform solid. So for a cylinder, that whole mass is mr squared. The other thing that you can think about is what's the relationship between angular velocity and linear velocity? Oh. Okay, so someone answer that question for me? Yeah, good. Good. All right, so we have to take that into account as well. Yeah, all good. Now we understand. Fantastic. Okay, so I'm gonna say that C is outside the scope. All right, I don't think that we're gonna have those types of computations, so let's not worry about that. Now, let's go ahead and do D because that is a mechanics question. All right, so for D, let's see. So this is now a 2D kinematics question. All right, and so, all right, so here I have this. So what we usually do is use the y direction to find time. All right, and then we can then choose to use the time in the x equation. All right, so bear with me while we go through that. All right, so change in y is equal to v naught yt plus 1/2 a t squared. All right, now it says that this thing goes off horizontally. All right, so that means that I have some initial velocity in the x direction and 0 in the y direction. Is everybody with me there? Okay, great. So that term drops out. All right, so now my change in y is equal to 1/2 at squared. All right, I know I'm going to go ahead and solve for t. So 2 delta y over a is equal to t squared. So t is the square root of 2 delta y over a. All right, and so 2, my delta y is negative 0.75 because I'm going from positive to negative. And then a is negative 9.8 because we're just dealing with gravity. And when I plug and chug, I get 0.4 seconds. Everybody with me? Great. Okay, so then now we're going to use the independence of the x and y directions to get an answer here. All right, so I'm going to use the same equation. Change in x is equal to v naught xt plus 1/2 a t squared. Okay, so what is the acceleration in the x direction in projectile motion? 0. So that one drops out. That's great. All right, and then change in x. What is linear velocity compared to my angular velocity? So v is equal to r omega, right? And then t. All right, and then we just plug and chug. 0.1, 25.6 radians per second, and then 0.4 seconds. All right, and then when we get out of that is I need a calculator because I can't do that one in my head. Basically 1 meter. I hate it when you go through all of that work and you get 1. Okay. Does anybody have any questions? Or 0? Yeah, so no problem. So 1/2 mv squared becomes 1/2 big M, because that's the mass, and then linear velocity to angular velocity is r omega squared. So I just simplified that to 1/2 r squared omega squared. No problem. All right. All right, I'm going to go ahead and put up part E, and then we're going to be done. All right, let me get rid of this. All right. Oh, sorry about that. I cut out part of the important piece. Give me 1 second. There's a lot of screenshotting that needs to happen here. All right. Okay, so there's the info that we need. Fantastic. All right, so part E, so it's looking at this piece of the question here. A sphere of the same mass and radius is now rolled instead of a cylinder. The rotational inertia is this thing. Is the total kinetic energy of the sphere at the moment it reaches the floor greater than, less than, or equal to? So this should be a layup. If it starts at the same height, then at the end of the day, it's going to have the same kinetic energy, because all of your potential energy has to get converted to kinetic energy. Everybody okay with that? So that one's equal. So same height means same kinetic energy. All right, so now here's the more difficult question. Is the rotational kinetic energy of the sphere greater than, less than, or equal to that of the cylinder? All right, so what do we think? So which one's going to rotate faster? The sphere or the cylinder? The sphere. Okay. So the sphere is going to rotate faster. All right, and we can note here that the rotational inertia of the sphere is less than the rotational inertia of the cylinder, right? They gave that to us. And then since V is equal to R omega, the sphere is going to rotate faster. It's going to move with greater speed. All right, and therefore we're going to have more linear kinetic energy. Okay, so I'm going to have more linear kinetic energy. All right, because of this. All right, and then because the total kinetic energy is the same, that means that my rotational one has to be less. All right, because K is equal to L plus R, right? Linear plus rotation. All right, so if this is the same and this goes up, this must go down. Everybody done with that? That's how I had to think about that, which is not easy logic. Will we need to memorize or remember? Oh, no. They'll give those to you. Goodness, I don't know them. They will give them to you. Don't worry. All right, last question. Is the horizontal distance the sphere travels greater than, less than? All right, so we've actually already answered this question, right? We know that we have more linear energy, right? Right here, more linear energy. Okay, great. So if I have more linear energy, then I have more linear velocity. All right, and then change in x is just equal to v times time. All right, and so if this goes up, my distance goes up, so it's going to be greater. All right, so I think these are the types of questions I would expect. A little less computation, a little more of that. All right.